Hi everyone, we are up to tutorial 8. So this is our second video, or our second week, exploring two-way Anova. So we're going to continue on with the story from last week. We're looking at the beer goggles dataset. So this is whether or not, this dataset was exploring whether or not the amount of alcohol that a person consumes changes the amount of attractiveness they see in someone of the opposite sex. But the interesting twist to this dataset is we're also comparing differences between males and females. So let's just make sure my dataset has loaded. It has. Let's just bring my variable windows in. Fantastic. So, because we are just continuing on with the story, I'm not going to bother with the backstory this week. If you have forgotten, please go and have a look at the other video from tutorial 7, and that'll take you through steps 1 all the way up to the Anova. I am very quickly going to rerun the Anova with the margins and margins plot, just so that we can remind ourselves of what the data looks like. So as a reminder, we did have this interaction going on, where we see males had slightly higher scores of attractiveness than females at 0 and 2 pints, but at 4 pints we get this disorderly interaction happening, where males cross over and are now significantly lower, or are now substantially lower, is probably a better word. We don't know if this drop-off is significant yet. All we know is that it is a substantial change. Male scores almost get cut in half. But this is an interesting point, right? There is this massive change, but is it statistically significant? Like, I had to correct myself then. So how do we know if this is a statistically significant interaction? How do we know if that swap over, if this change from here to there, does actually represent a significant shift? And this is what our contrast testing is for, and what we'll be looking at today. So just as a very quick reminder, let's look at the main effect. Let's try and look at the two-way Anova. So this is what we saw last week. The R squared was 61.11%. We saw the interaction was significant on 2 and 42 degrees of freedom. And we also saw that pints had a main effect, but whether or not that made sense to interpret that was questionable. And given that we have a significant interaction and it's disorderly, my recommendation would be to say that it's significant in your conclusion, perfectly fine. I would make a comment to the effect that it's not something that you really want to be interpreting. So that's how I would approach this if I had to write up some sort of conclusion, saying that, okay, yeah, it looks like there might be a main effect, but really there's a significant interaction, and that's what's important, that's what needs to be focused on. So that brings us up to speed. We also had our margins, our marginal means, which showed that at 0 points for males it was 66.88, for 2 points for males it was the same, but for 4 pints for males it drops off quite a lot. Then for females it's 60.62, then 62.5, and then it drops a little bit to 57.5. So really it seems like males at 4 pints have this drastic shift, and otherwise it doesn't look like there's much happening. Like last week, as I mentioned, you can basically ignore the rest of this table because it's referring to tests that are irrelevant for what we're doing. We're just interested in this first column. So that brings us up to speed. If that does not sound familiar to you, I recommend taking a bit of time and going back and listening to tutorial 7. Otherwise, let's proceed forward. So because we have this disorderly interaction, my recommendation is not to interpret the main effects, unless you've otherwise been explicitly told to. Now, because we have a disorderly interaction, we need to think about how do we pull apart this interaction for contrast testing, for our second stage analyses. And there are two approaches. The first approach is called simple effects, and that's what we're going to be doing today. Simple effects are all about looking at one group at a time. And we'll talk a little bit about how this works in a minute. But it's a really clear way of seeing what's going on. The other way is to go straight into running your traditional kind of contrast testing, like what we did in week 6, on your interaction. Now this is actually kind of complicated because it's hard to pick out what it is that you should be examining and how to interpret that. And if you do the full interaction contrast sets, so if you do all the possible contrasts, it takes a lot of time. So simple effects is much more common, and that's what we're going to be doing today. And then next week we'll look at running the contrast directly in the interaction, which is a bit more complicated. So the idea of simple effects is effectively that we're going to run a bunch of one-way Anovas on one IV against the DV, and each one-way Anova is going to be set at one level of the other IV. So we're going to be looking at one-way Anovas effectively of gender and attractiveness. And the reason why I'm doing this is because gender has 1 degree of freedom, or in other words, gender only has 2 groups. What this means is if we have a significant effect, we can just look at the means of gender at that particular level of the other IV, and we don't have to do anything further. We will look at doing it the other way by looking at the one way of alcohol on attractiveness afterwards, and I'll talk about the complexities that come up. But we're going to look at gender first because it makes it nice and easy. So we're going to have a one-way Anova of gender and attractiveness for those who had 0 pints. So we're just going to look at males and females who had 0 pints, and we're going to ask whether or not their mean attractiveness is different. Another way of thinking of this is effectively just a t-test. But we're going to call it a one-way Anova because technically that's what we're doing. And then we'll do the same thing, so another one way of gender and attractiveness for those who had 2 pints. And then one last time for those who had 4 pints. So we'll have 3 separate tests. Now you can use the contrast command to obtain the one-ways all in one go. And you can use test to obtain some pairwise comparisons.